Maybe I can show you the class.
Very good.
Hi.
Hello. Michana miwima. Michana miwima.
Mchana mwema.
Habari yako. What is habari yako?
How are you?
Oh, thank you very much.
Okay, we can start. Hello, everyone. Students, teachers, organizers, partners, speaker, and guests. Greetings of all. I'm Tamadur Saleh, founder of Metrology for All platform. First, I would like to welcome you all. Thank you for joining us today. Also, I would like to thank my friend Amy, who introduced me to the center, and Mr. Michael, head of the Mombasa, Kenya Olive Rehabilitation Center, for his great response and welcoming the idea. Also, I'm grateful to my friend, Engineer Ahd from Fluke, for his endless support, and my gratitude extend to Amotic team for their great response and contribution to this event and be here physically. But I would like to take a moment to introduce Amotech team, Mr. Machacha, Catherine, Bess, Edwin, and Mr. Michael, the head of the Mombasa, Kenya Olive Rehabilitation Center. We are so excited to have you on board. Really, thank you for your great efforts. I appreciate it. So we are most grateful to have your participation. Welcome to our platform. We launched a platform, Metrology for All, to increase awareness of metrology. All activities in this platform are totally voluntary. Some of the goals are conducting periodic training workshop and voluntary training programs in African countries to encourage writing and publishing simplified books in metrology, distributing to school and universities, to communicate with National Institute of Metrology in African countries, seeking voluntary training programs, adopting joint scientific research to be published in scientific journals, to assist those who wish to conduct research, publishing scientific articles and participating in conferences. We achieve our aim through the passion and hard work of our team of volunteer scientists. Among the volunteers are a fantastic team of physicists, engineers, and chemists in measurements and calibration laboratories in developing countries, alongside with scientists from non-developing countries working in the field. To disseminate the concept of volunteering work in this field and encourage others to participate in it. We are so pleased to organize the online summer school on basic metrology for the Mombasa, Kenya Center. That suits one of the main goals of Metrology for All platform in increasing the awareness of metrology in Africa. The purpose of this program to introduce the students the basic concept of metrology and explain to them the importance of metrology in our daily lives. This great effort will definitely result in a better understanding of how critical and important test, measurement, and metrology are, even for the very young generation. Thank you again, our partners, Amotech team and Fluke for their great contribution and endless support. It is my honor to introduce the second talk, Mr. Michael, head of the Mombasa, Kenya Center. Welcome, Mr. Michael, go ahead.
Thank you very much, Madam, for this opportunity. We are very grateful. We are humbled that you were able to accept to have us on board on training Metrology for All. And we want to thank you very much because we are a very humble school, a very down-to-earth school. We do not expect to have you pick us to be able to take part in such a very important event. And so that's also going to help the children that we have to be able to grow up understanding what they are able to become in the future. You know, many of us in Africa and wherever we live, some of us, the children grow up without knowing what they want to become, without seeing, you know, because if they are able to see some of these people who have excelled different careers, if they are able to hear them and learn from them, that's when they are able to aspire to become. And so we want to thank you very much for picking on us and for allowing these children to be able to learn and to also aspire to be great people in the future and to be able to continue in their careers as they aspire to become what they want to become in the future. So thank you very much for this opportunity. I know the children are going to enjoy. We are also going to enjoy, and they are going to be able to learn quite a lot of things. Thank you very much for giving us the opportunity. We are very grateful. Thank you very much.
Thank you very much for your kind words. The third talk from Amotech Africa team. Go ahead, Catherine.
Hamjambo. Vile mmesikia, mimi naitwa Catherine, nimetoka kampuni inaitwa Amotech Kenya. Sisi tuko Nairobi, lakini tulisema tunafanya biashara kila mahali Kenya, lakini ofisi iko Nairobi. Sisi tunahusika katika mambo ya test and measurement, which is metrology. Na siku hii ya leo tumeshirikiana na Metrology for All kuja hapa tuweze kufanya kuwasomesha na tusome pamoja mambo ya test and measurements, na tumeshukuru sana. Sasa wageni wetu hawajui Kiswahili lakini najua nyinyi mnajua Kizungu, sio? Yes. So we speak English. Okay, ama tuchanganye yote. So mimi naitwa Catherine na nitakuwa na nyinyi kutoka leo hadi siku ya Ijumaa. Asanteni.
Okay, thank you, Catherine. Thank you for your nice work and your great efforts. On behalf of all who work so diligently, extend sincere welcome to each of you. It gives me great pleasure to declare the session open. We are looking forward to imparting useful skills and knowledge on the students. The session chair, Engineer Osama Mulhim. Firstly, he presents a talk in 15 minutes about the importance of metrology, and he runs the session. Welcome, Engineer Osama Mulhim.
Thank you, my friend, Dr. Tamader. Okay, hello, my friends, how are you? Machana miwema. Habari yako? Are you happy? Yes. Very great, very good. Okay, I will share my screen. Can you see me? Yes. Excellent. Okay, so I will share my screen now so I can start. Okay. Can you see me now? Yes. Very good. So my name is Osama. Okay, what's my name? Very good. Okay. In Arabic, it's written like this. Okay. Osama, from right to left. In English, it's from left to right. Okay. Can you see this photo? Yes. Guess who is Osama here? This one or this one or this one? This one? Yes. Very good, very good. Okay. Guess where is this photo, you think? Where do you think this photo? Mombasa. This is in Mombasa. Okay. So I was there around 12 years ago. Okay. I will tell you the story later why I was in Mombasa. Okay. Yes. Now I want to tell you what is the meaning of Osama. You know what is the meaning of Osama? No. No. Okay. Yes. What is this? Lion. Lion. And this one? Lion. Another lion. And this one? Lion. Lion. What is the difference between three lions? This one is a running lion. This one is angry lion. And this one is calm lion. Okay. So Osama is the calm lion. It is not the angry one. It's not the running one. Now you know what is the meaning of Osama? Yes. Okay. Okay. The calm lion. So don't be afraid. Okay. Yes. I'm just calm lion. Okay. Yes. Good. Now, you know where I am staying now? No. I'm staying in United Arab Emirates in Abu Dhabi. Okay. You know where is United Arab Emirates? Okay, so it is here. It is here in this location. Can you see this location? Yes. Here is Mombasa. Here you are staying here now. Okay, you are in this location. You are in this school, Olives Rehabilitation Center, right? Yes. Okay, so you are here and I am here. Okay, so if I want to come to Mombasa, I have different, let's say, possibilities to reach there. One possibility is to come by car. Okay, so if I want to come by car, I have to go from United Arab Emirates to Saudi Arabia, then cross the Red Sea, go to Egypt, then go down south to Sudan, then to Ethiopia, then to Kenya, then to Mombasa. Okay? You know how long is this way? It is 7,600 kilometers. Okay? 600 kilometers. And if I drive by car, it will take me continuously 136 hours, 136 hours. Okay. How many days? More than 5 days, about 6 days. So it's a long journey. So another way, another possibility to come from Abu Dhabi to Mombasa is, what is another possibility? To come by plane. Yeah, with the plane. Yeah, the plane, you know what is the speed of the plane? The speed of the plane is very fast, about 700, 800, sometimes 900 kilometers per hour. Okay, so it's much faster than the car. So I will come directly this way. Okay, this is the shortcut way, and it will take me only 7 hours because plane is much faster, more than eight times or 9 times the speed of the car. What is another possibility? Okay, if I come by rocket, okay, by rocket, okay, it will take me half an hour. But unfortunately, in Mombasa, there is no airport for the rockets. So I will forget about this option. Okay. You know what is the speed of the rocket? The speed of the rocket about 7,000 kilometers per hour. Yeah, like 7 times or 8 times than the airplane. Okay.
Yes.
What is the fastest thing in the world? You know what is the fastest thing in the world? What is it? The light. Okay. The light is the fastest thing in the world. Okay. You know what is the speed of light? It's 300,000 kilometers per hour per second. Okay, 300,000 kilometers per second. So from Abu Dhabi to Mombasa, it will take me just less than the blink of your eyes, like this. Okay, very fast. And you know how I can speak with you now? Because my photo is traveling to you with the same speed of the light. Okay, so I am speaking now with you. You can hear me directly because my photo is traveling to you very fast with the speed of light. Okay, although we have the distance between us is about 3,500 kilometers. Yeah, we have very big distance between us. Okay, so this is the technology. This is why we need our country to be advanced. Okay, so things will be much easier, faster, cheaper. Okay, good. You know why I am happy to be with you? Because I was a kid. One day I was a kid, same like you. Okay, and I was working like very junior, like office boy. And step by step, when I went to school, then I went to university, and step by step, I became meteorologist and I became president for one organization. Then I'm an advisor, I'm engineer, okay? So I need you also to be same and better than me, okay?
Yes.
Promise?
Promise.
Okay, so I want to see this, inshallah, in the future. Okay, so now, how do we know, you know, where is the location of this car? Where is the location of this airplane? Where is the location of this person? Okay, how do we know the location of these things? Because our Earth, our planet, the Earth, is surrounded by advanced technology, surrounded by satellites. Okay, these satellites are connected to each other, and with the same speed of light, they are exchanging the information and telling us where is Osama and where is Mombasa and where is the car and where are my kids. Okay, so with this advanced measurement tools and technology, we know every single centimeter here in this planet. Okay, so this is why we need measurement. We need measurement because measurement is very important for our communication. Measurement is very important for our health. Measurement is very important for our safety. Measurement is very important when we want to buy and sell, right? Okay. So from the moment that we wake up from our bed every day, we wake up at, for example, 6 o'clock or 7 o'clock. First thing, we look to the clock. Then we go to school at certain time. Okay, we come, we buy things using measurements. We sell things using measurements, right? So measurements are very, very, very important. Correct?
Yes.
Excellent. Okay. So I told you that because of the speed of light and we are using this advanced technology, we are exchanging this information, okay, with the speed of light, because the speed of light can rotate around the earth in 1 second 7 times. Okay, so every 1 second the light can rotate 7 times around the earth. So it's very, very, very fast. Okay. Okay. So now I will tell you why I was in Mombasa. Yeah. In 2009, all people, all meteorologists, all, let's say, in charge people, okay, of metrology, of measurement from all over the world, they came to Mombasa in 2009. You know this place?
Yes.
Okay. Where is this place? Yes, very good. Okay, so this is here inside the hotel, and actually we were discussing the measurement. We came to Kenya to discuss the future of measurement, and during my stay also I enjoyed your food. I enjoyed your stay and to talk with your people. Okay, and also I enjoyed dancing with your good and handsome men here. Okay, what is this tribe called? What is this dress called? Yes, excellent, excellent. Okay, so I was in Mombasa in 2009 to talk about, actually to discuss the future of measurement. And I hope that you in one day also to be better than me to discuss also the future of measurements, the future of medicine, the future of engineering and any other things, okay? But you need to study hard, okay? You promised me, right? Excellent, excellent. Okay, now, I want to tell you here what is the story of the meter. You know the meter?
Yes.
Now you can see me, right? Okay, good. Now, this is, okay, this is the meter. Yeah, and I want to tell you what is the story of the meter. Like 5,000 years ago, there was a king in Egypt. Okay, this king, it is the one who built the pyramids. You know the pyramids?
Yes.
Excellent. So this person, this king, he said, I want to make a very good construction for these pyramids, and I want it to be very beautiful and very precise. So he said, that king, he said, I want to define that what is the length, what is the standard length, okay? So he decided that his arm from here, okay, to here is the unit of length measurement, okay? So from his arm, they produced one granite plate, one granite, okay, column, yeah, and called this column called the royal cubit. Royal cubit, okay? What is called? What does it call? Royal cubit. Okay.
Yes.
Okay, very good. So, and from his arm, so they produced this royal cubit, and they made and distribute a piece of wood for each worker. Okay, and from this wood, they made the very accurate and the beautiful pyramids, which is very beautiful. Until now, we are very fascinated with this construction. Okay. So measurement is very important to make accurate things, to make beautiful things, right? Then another king from United Kingdom, okay? His name is Henry the First. this man, he said, no, I don't want the arm of the king of Egypt to be the reference. I want the distance from my nose to here, okay, is the distance. So he measured this distance, okay, up to here and said, oh, this is the length. This is the length that we want. And this distance is called yard. Okay, it's called yard. 1 yard is equal approximately 92 centimeters. Okay, so 1 yard is how many centimeters? 92. Okay, hello, can you hear me?
Yes.
Okay, so 1 yard is equal to 92 centimeters. Then another person came and said, no, 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 the distance, the standard length, I want it to be, it is the length between my knees from here to here, okay? You see where I am pointing?
Yes.
From here, from this knee to this knee. So he said, I want this distance to be the standard length. Then the French, they came and said, no, 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 we cannot continue like this. This is miserable. This is, we cannot, okay, every day, and every king, he wants the measurement depends on his body. So they said this great person, he called Charles Tilran, okay? This scientist, he said, I want to connect the length, okay, the meter with the second. So he took, this is the pendulum, you see, this is the pendulum, okay? This is, we call it pendulum, okay? Pendulum, okay? Can you see it? Okay.
Yes.
So he said, I want to find what is, okay, here, from here to here, it will take some time, right? So once this time is equal to 1 second, this measurement, this length, I want to call it 1 meter. Okay, so this is how the first trial to make the first 1 meter. It is from the pendulum. It's from the pendulum because the time if the length of this pendulum is 1 meter, the time for the traveling from this position to this position is 1 second exactly. And this is how they made the clock. Now you can make a clock also. If you know this principle, now you can make same clock. Okay, yeah. So, but unfortunately, not everybody get convinced with this idea. So they said, no, 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 we need another definition. We need another, okay, way to define the meter. So the French said, okay, let's measure the circumference of the earth, okay? The circumference of the earth. And let's take one part of it, okay? One part of it and call it meter. So they measured 1/4 of the circumference of the earth divided by 10 million parts, and they took one part and they call it meter. Okay, so the meter is equal to 1 part of 10 million parts of the quarter of the earth. Okay, so this is the earth, and this is 1/4. You see where I'm pointing on this stamp?
Yes.
Okay, so they took 1/4 of the earth, divided this quarter 10 million parts, and so they took one part and they call it meter. So this is how they invented the meter. Okay, now you know how they invented the meter, right?
Yes.
Very good. Okay, and this is the first meter ever produced in the world? It was invented in the 1875. Okay, 1875, around 100, let's say 40 years ago. This is the first meter ever invented. And from the meter, they produced the kilogram. Yeah, and these two units make the basic for our accurate measurement in these days. Okay, so this is the kilogram, first kilogram, and this is the first, okay, meter. Okay, so till now, if we want to check some things, is it accurate or not accurate? This is mass. Okay, this is the mass that we use in the grocery shop. Yeah, it is here. How many kilos? Two, right? It's 2 kilograms. 2 kilograms. But is it 2 kilograms? What is the balance giving us? It is 1.845. Okay, so it is less than 2 kilograms. That's why we need always to go and calibrate our instruments. Yeah, because we cannot guarantee that this 2 kilogram is really 2 kilograms. We need to check it. So we send our masses to the labs, to calibration labs, to calibrate our instruments, okay, and to provide us with accurate measurements. Okay, now you know why we need good measurements. Okay, now, do you think that measurements is easy or difficult? You think measurements is easy or difficult? It is what? Okay, I can't hear you well. Okay, but now I want to check, okay, with you. Okay, you see these cans? You see these cans? Now I'll stop sharing to play with you. Okay, let me here. Let me stop. Excuse me for 1 second. It was virtual. Okay, this is Engineer Ahmed. Okay, say hello to Ahmed. Say hello, Ahmed. Hello. So Ahmed is from Egypt also. He's from Africa. And also he wants to be an engineer, same like you, inshallah. Okay, now I want to play with you something. Okay, you see this? Yes. Okay, what is this? Okay, this is a can, right? What we call, this is circumference, right? This is the circumference of the can. And this is the height of the can, right? Yes. Okay, which is longer, the circumference of this can or the height? Which one is longer, the circumference or the height? The circumference, right? Yes. Okay, so now this is the one. Okay, now I will put another one here. Which is longer now, the height from here to here or this circumference? The height. The height is more than the circumference? Yes. Okay, now let me check again. I will put another one here. Okay, which one is longer, this circumference or this height? The height. The height is longer, right? You said. Okay, so I will put another one and you will remain saying it is. Okay. Higher. Add another one. It's higher, right? And I will add another one here. Okay. And you believe that this height is more than this circumference, right? Yes. Okay, so let me check. Okay, this is a rope. This is a rope, and I will make this rope here to measure. I want to measure. So this is the circumference. This is the circumference, and let me check. Wow. So which is longer now? No, the circumference is higher than the height. Okay, so you see the idea is that with eyes we cannot measure very accurate. Okay, we cannot measure very accurate with eyes. We need measuring tools. Okay, this is the idea of this experiment, that always you cannot believe on your eyes. You need to measure to make sure that things are correct. Okay, you agree with me?
Yes.
Very good. So thank you very much, my friends. And now I will leave the floor, the mic, for Mr. Hari. Hari is my friend also from the United Arab Emirates, and he will talk about the importance of also the about metrology and the importance of metrology. Mr. Hari is working as calibration engineer in a calibration lab in United Arab Emirates, Middle East Calibration. Middle East Calibration. Mr. Hari, please.
Hi, sir. Yeah.
Okay, bye-bye.
Hi, friends. You can hear? Can you hear me?
Yes.
Yeah, yes. How is everything? Now we are going to the session about the metrology. The respected Osama sir discuss something related to metrology and measurement. So some terms he mentioned, like metrology, calibration, and meters, length, those type of terms he mentioned. So whatever the terms actually you are not understanding properly, you please make a note if possible. So we can start with our topic, metrology. You can hear just a moment. You can see this. You can see this?
Yes.
Yeah. We can start from the topics metrology. So the terms metrology is actually comes from two Greek words called metrons and logos, which means the study of measurement or the science of measurement. You know, there are different types of studies are here. We can we have a medical field, we got physics, we have chemistry, biology, different types of area is there. Same like there is an area or there is a science called metrology. So what actually we are going to study? Metrology. What?
Metrology.
But then what is metrology? First of all, we should know what exactly the meaning of metrology. What exactly the meaning of metrology? Metrology means it is the science or study of measurement. In our day-to-day life, we know the importance of measurement. You have experience of measurement of different things. Same like if you want to measure the length of your book, how you actually measure the length of your book? How you measure the length of your book? You have a book. If you want to measure the length of the book, how you exactly measure the length of the book? You use ruling, steel rulers, scales, or measuring tapes to measure the length of the book. So that is actually the part of metrology. So we are going to so one term actually now we learn the first term. What is the term? Metrology. That term you should understand the knowledge, you should understand the meaning of metrology. That means what is the metrology? Now I say, what is the definition of metrology? It is the science or study of measurement. What is metrology? Yeah, it is the science. It is the science or study of measurement. So in metrology, we all are learn about. We all studies the types of measurement, how to measure each and everything, and what are the things. What are the things we require to measure, and what are the different types of measurement. These all things are comes to the field called metrology. These all things are in the same, under the same roof we called metrology. So whatever the things which is related to measurement, it is undercomes metrology. You got my point? So whatever the terms which is related to measurement, it is comes under metrology. So we can say that metrology is the science or the study of measurement. So the purpose of this meeting or the purpose of this session is, after completing this session, some of you have some terms which is stick on your mind. Somebody which used what is exactly the metrology, what is the benefit of metrology, where exactly we using these terms of metrology. Okay, so just say, let's say now I say we discuss like what is the length, what is the length of this book, how you measure the length of this book. You are using steel rule or measuring tape, or what we call, here you can see we are using steel rulers, are using measuring tape, we are using to measure the length of the book. In this steel rule, you oftenly see some bars here. Here's are centimeters and millimeters. I think you have the idea about centimeters and millimeters, right?
Yes.
Yes, you have the idea about centimeters, millimeters, and then meter. Then what is the next level? We started from millimeter, then centimeter, then meter. What is the next level? Kilometers, right? So for smaller object, we use millimeters. For larger one, we using meters or kilometers. So we have to study about different types of measurement in metrology field. Before that, there are 7 international standard base units are there. These 7 international base units are actually the foundation of what we call the metrology. So that we should know about the 7 international base unit. SI unit. SI unit means international standard, standard international. Okay, just a moment. It's just slow, something is. Let's start from length, then time, amount of substance, electric current, temperature, luminous intensity, and mass. These are the 7 standard in the international standard base unit called length, time, amount of substance, electric current, temperature, luminous intensity, and mass. If you want to measure any type of measurement, that is any of this measurement, any of this unit is included in that measurement. Just a moment. Just a moment. Just a moment. Okay, we can start from length. Now we discuss about length. We discuss about the measurement of the length, how to find out the length of your book, how to find out the width of something. In front of you, there is one desk is here, right? You are sitting on the bench, desk is there. How you find out a distance? To measure a distance, there should be 2 points, one initial point and one final point. We are measuring the distance between 2 points. How you usually measure the distance? If you want to measure the length of your pen, how you measure? Could you please take a pen? Take a pen. You can hear?
Yes.
Yeah, you have pen?
Yes.
Yeah. How you measure the length of that pen? How you measure the length of the pen from where to where?
Yes.
The top to bottom, right? From from top to bottom. So to measure the length, there should be minimum at least 2 points should be there, right?
Yes.
Yes. Measurement of the length is the process of measuring the distance between any points in terms of width, thickness, depth, and height. If we want to measure the height, if you want to measure the length, if you want to measure the thickness, everything is comes under the SI units length. You got my point? The distance, width, thickness, depth, height, everything is comes under length. So the unit of length normally we use meters. The SI unit of length is meters. What is SI unit of length? Meter. Okay. So we are talking about the SI units, standard international units. The first in the SI unit is length. Okay. So we should have a minimum idea about length, how to measure the length, what is the importance of length in our life, what are the importance of the length measurement in our life? You can say, can you say what is the importance of length measurement in our day-to-day life? Some example I can say that if you want to fabricate a bench, you have an idea how much height should be there, how much width should be there, and how much is the thickness of that wood. Everything we have an idea, right? If we don't have an idea to fabricate a bench or desk without any measurement, how we can actually fabricate the same thing? So every time if you want to build or create everything, you should require what? Length measurement, right? You want to measure the length. If you want to build a house, length should be measured. If you want to make a door, length, width, height, thickness, everything should be there. So that purpose we are using some length measuring devices. How actually we are measuring length? We can use steel rulers. You know steel rulers?
Yes.
Yes, steel rulers. Then measuring tapes are there. Sometimes we are using calipers. Did you see this caliper? No. Sometimes we are using screw gauges, but in commonly we are using this ruler and measuring tape to measure the length in our day-to-day life. I am talking about our day-to-day life metrologies. If we are going to higher end, it is little bit difficult. So we can discuss about our day-to-day metrology in our day-to-day life. So length measurement, where exactly we are using the length? If you want to measure something, like if you want to measure a door length, or you have to if you want to create if you want to make a door, wooden door. If you want to make a wooden door, you need the length. You need the length of that frame. At least your home have a frame, right? The door is fixed on that frame. If the door is too smaller than the frame, air, light, everything is coming into your house. If the door is bigger than the frame, it won't fix to the it won't properly fix. So we have to measure the length of the frame first, then we have to make the door. So that time we are using this metrology in our day-to-day life. Which metrology? Measurement of length. You got my point? What actually we are discussing? What actually we are discussing now? Metrology. And the first measuring and first unit is length. How many SI units are there? How many SI units? 7 SI units are there. The first SI unit, SI base unit, we are talking about the length. We are talking about the length. Second one is time. Time. What exactly, where exactly we are using time? In a daily life, how many times we use the word time? What are the different terms which is indicated to time? And what you understand about time? First of all, if I am asking to you, what is time? How you respond? What is time? Somebody can explain what is time? In a simple knowledge, if it is right or wrong, doesn't matter. What is time? When we talk about time, everybody will look to your watch, right? Or clock. And you will point it to the clock, that is time. Or point it to your watch, that is time. But actually that is time. Can you hear? Hello? Yes. Time actually in ancient days, before starting the topic's time, in ancient days, normally the ancient people using two things in their time. One is they are calculating as they are sleeping, and one is they're calculating for their how much time they wake up. So the time for ancient people, the time they are using related to, first of all, they're related to or find out the time with the help of sun. Sun. Yeah, sunlight, sunlight. Yes, with the help of sunlight they probably measure the time. So nowadays we are measuring the time with the help of watches, clock, digital watch, different types of measuring instruments which we used to measure the time. What is the time in Mombasa now? 4 o'clock?
Yes.
4 o'clock. Yes, 4 o'clock. Here in UAE, the time is 5. Yeah, here in UAE, the time is different. Time is different in UAE also. So how you measure the time? When I ask what is the time right now, how you measure the time or how you find out the time? With the help of watch or clock or whatever it is, that is actually time measuring instrument. We can say that time is probably the most measured quantity on earth. It tells us when to wake and when to sleep, when to plant crops and when to harvest them. It helps organize our lives and coordinate our activities. So in our day-to-day life, time has very much importance. In earlier days also, we have a time to crop something, plant something. You cannot plant a tree in another month. You have, when you actually plant paddies or what we call different types of crops, you plant in different season, right? You have to farming, farming, cultivation, farming. Each crop is planted in a particular time. There should be a time. Time is probably the most measured quantity on earth. It tells us when to wake, when to sleep, when to plant crops, and when to harvest them. It helps organize our lives and coordinate our activities. In science, we use time to measure and better understand countless things in our world. This time has very much important in our day-to-day life. For example, if you want to boil an egg, you know how much time need to boil an egg. You know, you want to boil the egg. Egg, you know, egg. Or you want to boil the vegetables, or you want to boil or cook the food. There should be a time required. If the time is too much time, you cook the food, or less time you cook the food. What is the difference? We cannot prepare the food properly. You got my point? The importance of time in our life?
Yes.
Yes. Normally, the basic unit, the second is used to measure the time, as well as enabling us to tell the time of the day. Accurate timekeeping is key to satellite navigation system, underpins the functioning of the internet, and facilitate time stamping for the transaction in financial trading. Ignore about those type of things. That is, ancient civilization used sundials. You know sundials? Just a moment. Just a moment. Just a moment. This is the sundial. Ancient days, instead of clock, these sundials are used. In sundials, you know, here is, you can see one center point, center stick is here. When normally, you know, normally when we are in sunlight, there should be shadow.
We can't see it.
You cannot see this?
Yes.
Yes.
You cannot see this? Okay, just a moment.
Engineer Harry, your screen, I think it's stuck. Okay. If
Just
you
a moment.
disconnect and connect again, please, or stop sharing and resharing again, I mean.
I think that sharing screen have some problem. Just a moment.
Yeah. I think it's maybe sometimes ago even, because I have this message.
Okay. Let me.
Yeah. And please, you have like 5 minutes also to give time to to Professor Hala.
Okay. Okay, we can meet again. Just a moment.
Okay. Yes, now you can reshare.
Yes. Now you can see?
Not yet.
Not yet.
Yes.
You mean the video, right?
Yeah.
No, the video is not running. You have to share your desktop, not the video.
Yeah, I
the
shared in the desktop. I shared. Okay, no problem. This one you can see?
Yes, this one, yes.
Okay, fine. Actually, the video is not running. Some technical errors is there. Initially, can you hear?
Yes, we can. But is it possible to make a presentation? You make the presentation, not the, make it as a presentation. Slideshow, like slideshow. Make it slideshow.
Okay.
No, you share. But once you share your desktop, not the PowerPoint presentation. Yes, now the video is running. Okay, you can go to the video. Now we are seeing your desktop. Yes, now we can see the sundial.
Yeah, okay. But here some technical issues are in my desktop. My laptop has some problem, I think. Just a
Yeah.
moment. Yeah.
This is just normal.
For the presentation. Sorry, guys, just a moment. There is some technical errors. I think that I'm taking a, there is some, I cannot,
Engineer Harry, I think the idea is clear, so you can move on.
hello?
Yes,
Hello.
Yes, yes. Sorry, guys. Time is valuable one, but that time my desktop, some problem was there. Anyhow, we can talk about the time. You can see my screen right now?
yes.
Yes, okay. So ancient days, actually we used sundials for measuring the time. But the sundial, it is depends on the shadows length and direction of the shadows, and it depends on the sun. You know the advantage and disadvantage of sundial. Sundial is only working when sun actually have proper light, or what we call, if any extra shadow. Hello?
Hello.
Sorry, guys.
Yes, Harry, we can hear you. And you have only 2-3 minutes.
Oh, sorry. Just my.
You can just focus on the time, please.
Yeah. Focus on the time. Okay, guys, we can say that there are 7 SI units: length, time, amount of substance, electric current, temperature, luminous intensity, and mass. What are the basic importance of these SI units in our day-to-day life? These 7 SI units are very much importance in our day-to-day life. For example, first we can say that length. Right now we discuss about the length, how much importance in the length, and the time, how much importance of time in our day-to-day life. For example, if you want to measure, if you want to make a food, if you want to make, if you want to go somewhere, everything is related to time. For example, if you want to cook some food, there should be a time. That time,
Harry, we cannot hear you. Your screen is stuck. Hello, Harry? Harry? Others can hear me?
Yes.
Okay. Thank you. So I think Mr. Harry has some communication issue. Okay. till he's coming back, I just want to conclude and thank him for this presentation. Now, yes. Okay, so what is the meaning of metrology? Science of science of measurement, right? Science of measurement. And what is the measurement unit of time? How do we measure time? What is the unit? Second or kilogram? What did you say? Second?
Yes.
Kilogram?
No.
Oh, excellent. Okay. Which is bigger, the centimeter or the meter? Centimeter? Meter. Okay. Meter or kilometer?
Kilometer.
So which is bigger, the centimeter or the kilogram? No, we can't. We can't compare centimeter to kilogram. Okay. This is length. Okay. And this is mass. We cannot compare different things to, okay, with same. Okay. So kilogram can be compared with a gram. Centimeter can be compared with meter. Okay. Okay. So now I will introduce my best friend, Professor Hala from Egypt. Okay. And
Yes.
you will enjoy 100%. You will enjoy her lecture. But, okay, because she is a real scientist, be careful. Now, before I introduce her, I want Professor Hala to inspire you, okay, and to tell you how to be a professor in metrology, in measurement, okay? Forget about Professor Hala, what is electricity, okay? We want to inspire them. How you became a professor in this field, okay? Tell them your story. I know it is not an easy, and we want them to be same like you.
Thank you, Osama, Mr. Chair. Welcome, guys. Welcome, Tamadur, Dr. Tamadur, Engineer Talat, all the audience. I'm so happy to be with you and to share my experience and my presentation with you. In brief, about myself, I studied electrical engineering, and I like electricity so much in the Faculty of Engineering, Cairo University, and I'm graduated, and then I continue my study, continue my master's degree, PhD degree, and perform experiments, measurements, studies, different things to improve my qualifications and to enhance my my experience in electrical engineering, in metrology, in scientific research. It's not easy, but it's interesting. I wish all of you all your dreams come true, but I wish to advise you to love what you do, and do your best to reach the top of everything. Try to reach the top of every thing you do, like what you do. Be helpful with others, because if you are a scientist, you should join other people with your experience and with your education, knowledge and everything, because science is for all, like metrology for all. If you help other, you will find many people help you. Never give up. Love other colleagues. I advise you to work in a team, because teamwork is always a perfect way to go to the top of everything. Thank you to be with you, and I wish to share with you my presentation, and I wish to have your admire, and I am with you in everything. If you have any question, please don't hesitate to ask me. And now let me share the presentation. Thank you, Sema.
Very
I'm so
nice
happy to meet you.
Me too, and very happy that you are with us, and you really give them a very inspiration advices. Really, if they follow, they will be very successful, inshallah, in the future.
Allah.
So what is the secret? What's the secret of success? If there is a secret.
The secret is first, you have to have a target. First of all, you have to have a target and do your best to
work hard. To work hard. Yes.
You have to work hard. Yes.
Yes.
It's not easy, but it's exciting.
I want you to tell them, was it easy for you to become a professor, or you spend the nights and the days and working all the time?
No, I spent my nights and days, and but it's interesting because I like this career.
Yes.
The key is the love. I mean, love in everything is the key.
Yes.
If you are a lover for your career and your hope and your plan, you have to have a plan. A good planning will help you to reach your target.
Okay, excellent. So having a good target, having a plan, and working very hard.
Yes, and love your work and your
love your work. Yes.
Yes.
Excellent.
I think it's a secret. The love is a secret. This is my idea. This is my belief.
Thank you. Okay, so Professor Hala, you have now, let's say, 20 to 25 minutes. Let's make it easy for them. Thank you very much.
Thank you very much. Can you see the presentation?
Yes.
Good. Can you hear me?
Yes.
Okay. Our presentation will discuss some basics and principles of electrical quantities, of metrology of electrical quantities, especially metrology. So first of all, I want to tell you a brief definition of metrology. In simple words, metrology is the science of measurement and its applications. Because metrology is a lifestyle, is a daily life for us. In everything in our life, we need to measure it, and we have to we have to make an applications or experiences using this measurement about everything in our life. So the first item I need to talk about is what is the measurement and why we measure. Why do we measure? Simply, measurements is something that make a relation between an object or anything with numbers and units. I mean, if I told you I am 25, that's it. Do you understand what the meaning of I am 25?
Your age.
With any number without unit, don't give any meaning. There is no meaning for any number without unit or any unit without number. So simply, measurement is a combination between numbers and unit for everything. In length, in temperature, in pressure, in electricity, in everything. If I told I am 11 or I am 168 or everything without units, there is no meaning. If I told you I am a meter, I am a kilogram, it's not. There is no meaning for this. There is no meaning for this sentence. I mean, if I told you everything without if I mention number without unit or unit without number, so there is no meaning for measurement. So measurement is a foundation of any investigation, especially in science, in scientific research, in our daily life. It's assignment of numbers to objects easily. If I told you the time without its unit, there is no meaning. You understand me? So if you, I want you to tell me, how old are you? May you tell me?
Yes.
One of you can tell me, how old are you?
13 years.
I can't hear.
Louder.
13 years.
13 years old, right? How tall are you? How tall are you? So if you told 150 meters, yes. You have to introduce yourself by your meaning with number and unit. Okay. So Osama told you or mentioned the calibration, and the calibration simply is a comparison between any value delivered from any device under test with the results or values delivered by a standard unit. I mean, if I ask you now, what's the time now with you? May you tell me what is the time? What's the clock?
Yes.
With me is 3:36. In how time? What is the time with you now?
4:30.
4?
Yes.
I mean, if now is 4:37 and you is 4:35 and Osama 4:38, which one of our readings is right and which is wrong? All of us must go to calibrate our hand watches and get the accurate or true value of the value delivered by the watch by comparing it with a standard watch. This is simply a calibration for any instrument in electrical, in medical, in health, in masses, in everything. To calibrate any device, we have to compare the values delivered by this device with a standard device but you have to choose the device with the same category or higher or best. I mean, you have to calibrate your instrument against a higher or at least the same or a higher standard, reference standard, to get the actual and the true value for your reading. So we cannot trust our readings without calibration. We cannot guarantee our results without calibration. So there is no meaning for any number gained from any instrument not calibrated. So we have to in order to attain the actual value, we have to calibrate the instruments in our life, all instruments in our daily life, everything. I think I have to share again.
Dr. Hala, your presentation is stopped.
Yes, it's lost, I know. Now, okay. So when we talk about calibration, we have to talk about calibrate some items we have to overlight or like calibration standards, SI units, primary standards, secondary standards, and working standards, and finally process instruments. Do you hear me?
Yes.
Yes, okay. So we have to talk about some fundamentals and some terminology of metrology to be aware of our life of metrology. We have to talk about international system of units, national metrology institutes, primary standard, secondary standard, working standard, and process instruments. It's a pyramid of calibration or traceability chain. First of all, why do we calibrate? Simply, we calibrate to increase our trueness of our measurements and also to increase our precision of our measurements and to reduce or decrease the error of readings, or in other words, or in more scientific meaning or more scientific words, to decrease the uncertainty of our measurements. So we have to know a little bit about uncertainty. Uncertainty is like an octopus. This octopus feeds on the doubt of the measurements. I mean, the uncertainty causes us to doubt the accuracy and precision of our measurements. And if the doubt is increased, or if doubt increases, this uncertainty octopus feeds on this doubt, and it makes him bigger and stronger, and it's not good to have a great margin of this uncertainty or of this doubt. So if we imagine that we have a value X, is a measured value X, and we don't know the true value. If we need to, or if we get the true value, we have to add this doubt our measurements into consideration to get our actual or true value. So the uncertainty is a margin of doubt plus or minus values should be added to the measured value. In simple words, uncertainty is a doubt of the measurement, so we don't believe in any value without plus or minus margin of uncertainty to be sure or to trust our readings. We have to refer all measurements of every discipline to the international system of units. We will go to international system of units later, but now we have to refer every measurement from industrial measurements to the international system of units by calibration. This is gained by calibration, by calibrating the industrial measurements against the higher standard, for example, working standard or secondary standard or primary standard, or every standard maintained in accredited labs or industrial standards or international national or international standard institute, National Institute of Standard, to give all our measurements refer to the international system of units. This is called the traceability chain or the measurement traceability pyramid. So we have to go from lower to higher till we reach the top of the pyramid, which is the international system of units. We have 7 SI units, 7 base units in the international system of units. This international system of units unify our measurements in every country, in every place. We have to, all of us, we have to unify our language in measurements. So we have 7 base units. First one is Moncher kilogram. This is the unit for mass, and its symbol is kilogram. And also Professor second in the SI units is the sample of the time.
Dr. Hala, are you sharing your screen? Because we cannot see your screen. We can see you only.
Okay, you cannot see the screen?
No, we are only seeing you.
Only now or since a long time?
Long time.
Okay. Moment. Now I'll share screen.
Till now, it's not shared.
Okay. Is it there now?
Yes.
Okay. You see this before? You see this slide before?
I think you left us on this
Alright.
with this slide. Yes.
All right. We mentioned that why do we calibrate to get an accurate and true measurement and increase our trueness and precision and accuracy of our measurements, and to reduce or decrease uncertainty. And we talked about what is the uncertainty. Uncertainty in simple words is a doubt of our accuracy and precision of our measurements. So it's good to reduce this value of the doubt. And in this picture, we can see if we measure any X value, for example, X value, and we want to know what is the true value of this X value, we have to add plus U and subtract minus U to the value to get the margin of the uncertainty or of our doubt, to say that this is a true value or conventional true or actual value of our reading. Without uncertainty, there is no meaning for this X only. I mean, if I told you this pen is 10 or 15 centimeter only. If I mention that it's 15 centimeter only, is not true. The truth is we can say that is 15 plus or minus 0.0001 centimeter as an example, because the actual or true value of our measurement for this pen is lying within a margin of uncertainty should be considered in every measurement we perform. You understand me? If you told me this pen is 15 centimeters only without plus or minus any margin of doubt, it's not true. It's not a true value of this lens. We cannot guarantee, we cannot be sure to say that this is 15 centimeters on. You understand me? So you understand what the meaning of uncertainty of measurement?
No.
Okay.
Come again.
When we measure anything in our life or tell about any number without plus or minus a margin of a little or a small margin of uncertainty, there is no meaning. I mean, I have to measure this pen again. If I say this pen is 15 centimeters, for example, and that's it. If I said it's 14 centimeters only, it's not completely true. It's a measured value or it's a nominal value. This is the nominal value of this pen, but it's not an actual value of the reading. To get the actual value of the reading, we have to add a margin of error. Let us say a margin of error of measurement, because when I measure this pen length, may I get an error in my observations, or the temperature affects the readings, or this pen is or the ruler I measured against, it's not completely true. It may be milli or micrometer added to my measurements. So to have a guarantee for my measurement, I have to get into consideration an amount of uncertainty value to be accurate, to be actual, to be true. Because the value stated is a nominal value. It is a nominal value. It's not a true or actual value. Got it? You got it or not?
Yes.
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 Okay. So to measure anything in our life, we have a measurement traceability pyramid. What the meaning of measurement traceability pyramid? Measurement traceability pyramid is like Giza pyramids in Egypt. We have a base of the pyramid and the top of the pyramid. All of us want to reach the top of the pyramid to be perfect. So we have to calibrate in different stages to reach the top. The top is called the International System of Units. What the meaning of the International System of Units? International System of Units unify all our measurements all over the world. Because if we produce, or if we have a production for this pen in Ethiopia, and the same pen is produced in Egypt, so we have both of us to follow the same units in our production and to refer our measurements to the International System of Units. This is a unified language of measurement. We have to, all of us, speak with one language for measurement. We have to speak in the same language to facilitate everything, to facilitate trade, to facilitate everything, okay? So to get this top of the pyramid, we have to calibrate our instruments to get the actual or true values. This means that we have to get the amount of doubt added to our measurement to get the top of the pyramid. Okay. The seven base units of the international system of units is kilogram, Moncher kilogram for mass, and professor second for time, meter man for length, Mr. Ampere for current, Dr. Kelvin for temperature, Candela for brightness, and the mole for substance. These are the 7 base units of the international system of units. Okay, so we have to refer all our measurements in mass, in time, in length, in current, temperature, brightness, substance, all of our measurements to the international system of units. And there are many derived units are derived from these 7 base units. For example, in current, on electrical current, on electricity, ampere is the unit of current, and the symbol of the current is A, referred to ampere. When we talk about the electrical international system of units, we have to get a brief knowledge or a brief information about what's the meaning of electricity. All of us know the electricity in lamps, in computers, in everything in our life. Everything surrounded us is working by electricity. Electricity, in simple words, is a flow of electrons in a circuit or around a circuit. 3 electrons transferred and go through the closed circuit to illuminate the lamp. And we have to know about the electrical plugs. The plug simply is a connectors, 2 connectors, male and female. And as we know, there is attraction between, in life, between male and female, also in electricity. The plug is a male connector, often with pins, 2 pins or 3, that match the opening and the female contacts in socket. When we talk about the electricity, we have some terminology of electrical. We have to know some about it, like electrical current. Electrical current simply is a motion of electrons, and the current moves from the negative charge to the positive charge, as we see in the right picture, from the negative charge to the positive charge, and go through a circuit to produce an electricity to have an illuminated lamp, for example. And the direction of the flow of electrons is the opposite direction of the flow of the conventional current. What is the electrical resistance? Every wire or conductor we have includes a certain limit of obstacles or resistance. When an electric current flows through a conductor, the conductor provides some resistance. This resistance known as electrical resistance. And every material in our conductor life has an electrical resistance. This is like if we have a power or energy, try to push the current into any conductor, there is a resistant man try to resist this flow. This is simply the meaning of electrical resistance. It's the resistance of the wire that electricity passes through it. What is the meaning of electrical voltage? The electrical voltage is the pressure in the line causing the current to flow through a wire. Like this picture, there is a push, there is a pressure of the voltage to move to pass the current into any conductor, and this is a resistance. Resist this flow and reduce this flow. This resistance depends on the material of the conductor, the length of the conductor, and the cross-sectional area of the conductor. So the actual measuring of these terms, I mean the actual measuring of voltage, the actual measuring of current, the actual measuring of resistance should be attained to get the true value of the electricity. If there is any wrong measurement of one of these parameters, we will get incorrect result of the electricity. So accurate measurement is an important, very important issue, very important role in our life. So metrology, we have to go back to the importance of metrology. Without metrology, there is no accurate results. We will face many complications and many false and wrong results. So it's important to measure. It's important to accurately measure. It's important to perform the measurements and its application. So it's important to take into consideration the meaning of metrology in your daily life, especially in this presentation.
ممكن 5 دقائق مثلا؟ ولا أكثر من الوقت؟
اوكي. يعني استوب شير ولا
انا قصدي انه يعني خلاص يعني
بعد ال5 دقائق يعني؟
ايوه بالضبط.
حاضر.
شكرا.
These parameters of electricity are under the simple principle called Ohm's law. Ohm's law said that V voltage equal the multiplication of the current by the resistance. So Ohm's law solve everything regarding the voltage, the current, and the resistance. The electrical quantities relationship is the main 4 quantities or 3. First, the ampere, the ohm, the voltage, and the power. The power is the multiplication of voltage by current, and in different words, we can say resistance by squared current or voltage squared by divided by resistance. So Ohm's law is a player in this relationship between electrical quantities. We will talk about the power generation. We get the power generated from coal, for example, to produce electricity, and we can get power from waterfalls, and we can get the power also from renewable energy sources or green energy like solar cells, like wind energy, to get greenhouses and get green life with a healthy life and cheap life also. We need to transfer or transmit our power and energy produced to the higher level the transmission lines and then reduce it by step-down transformers to distribute this electricity to homes, to factories, to shops, to everywhere. So we have to measure all these parts of our distribution or transmission or production of electricity. So we have to accurately measure everything to ensure our net results or our products to be electrical products like computers, like laptops, like mobiles, everything in our life depends on electricity. We have to ensure this result. We have standards in the metrology realm. We have primary standard for electricity to realize the ampere. We can get it by two primary standards all over the world, the Josephson effect for voltage and the quantum Hall effect for resistance to get the current. So we can realize the ampere indirect, not direct realization. We realize the ampere of SI units indirect. So we have to measure the voltage by Josephson effect. It covers up to 10 voltage, and we measure the resistance using quantum Hall system. Is a primary standard or voltage secondary standard or resistance secondary standard or industrial working standard like a digital multimeter or calibrator for sourcing and measuring the electricity. These are the standards to refer our measurements to the international system of units to be sure and to guarantee our measurements in electricity. So I want to give your attention to the importance of accurate measurements and the importance of the meaning of the metrology in our life. And if we measure 10 voltage, for example, the nominal value is 10 voltage and the true value is 10.000710, as you see. So we have to get the actual value of our measurements. We have to get it. We have to get it. So we can get these measurements by calibration. And when we say calibration, we have to remember the uncertainty. And when we call calibration and uncertainty, now we talk about the metrology. Also, we have high voltage standards to get higher voltage for transmission lines and something in our life. So very important to measure our instruments to electricity meters that we use in our homes and our factories. We have to measure all our electrical instruments around us accurately. So take into consideration that it's important to know the metrology science, the science of measurement and its application. In this presentation, application is in electricity, and you have very wide range of applications. You have applications in every realm and in everything in your daily life. So I want to, in the last slide of my presentation, to thank you and to give you some awareness about the electrical safety. You don't have to close the circuit of the electricity, because if you close this circuit, you will die. Simply, we will die. And if you repair any electrical instrument, you have to get the plugs disconnected. And if you connect the plugs, you have to check the wires. You don't use the damaged wires because you can it's not safe. And when you connect your plugs or your mains, you have to stand on a floor without water. You haven't stand on a wet floor. I mean safety is your job. Electrical fitting should be done by specialists in electricity. So you have to think safe and act safe to be safe. I want to thank you very much. And if you have any question, please don't hesitate to ask me.
Oh, thank you very much,
I know my
Dr.
presentation
Hala,
is
and thank you
slightly-
very much for the nice flowers also.
Thank you, thank you.
Okay, so please can you just stop sharing so we can see
Okay.
the colleagues. Okay. Okay, so Dr. Hala talked to us about so many things, and her presentation was very comprehensive one. So she talked about the measurement units, she talked about the elements of measurement. Yeah, she said that its measurement is the correlation between the three, or consistent measurement is three elements. First one is the value, the number. The second is the unit. The third is the uncertainty. Okay, so remember this from Professor Hala. This is very, very important thing. So measurement are three things. Okay, unit number, which is the value. Second is the unit. Third is the how much we are certain. Okay, how much we have like an error. She said she called it uncertainty. Okay, so three things. Remember these things. Okay. Again, she also talked to us about the SI system. How many basic units in the international system of measurements? 3 or 5 or 7?
7.
3?
7.
7. Excellent, excellent. Okay. And what are the most important measurement units for electricity? Most important things. Okay, you say yes or no. Mass, important or not important for electricity? No. Okay, volt, volt.
What?
Yes or no?
Yes.
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 Ampere,
Yeah.
ampere, important or not important? Yes. Resistance. Very, very good.
We have
Okay.
three important items or parameters in electricity: volt,
Volt
ampere, and current.
and current. Yes.
Sorry, volt, current, resistance, and volt. I
Yes,
mean
these
volt,
are the most.
ampere, ohm. These
Yes.
are the units.
Excellent, excellent. Okay. So also she talked to us about how to generate electricity. Okay. How do we generate electricity? From what? From sun. From
Yes.
wind. From power plants. Okay, like steam power plants. Okay. Okay, very good. And she talked also about safety. Safety. Okay, so please remember all these things from Professor. And the most important thing, remember that Professor Hala, she worked very hard to become a scientist and to become in this position. And the most important thing to learn from her how to be a successful person. Okay?
Yes.
So are you happy with this program?
Yes.
Very good. So I will leave now. I will say Asante. Okay. Assalamu alaikum. Bye bye.
Alaykum salam.
My colleague here also wants to say hello.
Bye.
I love
Bye.
Okay. 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 So anything, anyone wants to say anything? So we have a homework. We have a homework for you now. Okay. Next week, you have to prepare one page. Next week, you have to prepare one page about the 7 units. Okay? 7 basic units of the international measurement of units. Okay? One page. One page. give it to your instructor. Okay, the 7 measurement, 7 basic units. Okay, try to take a photo for this and send it to Dr. Tamada.
Yes.
Okay, promise? Okay, thank you very much. يلا السلام عليكم دكتور تماضر. بدك تحكي عندك تفضلي إذا بدك في أي شيء.
Thank you all for your effort. Really, I'm very happy. It is very inspiring, very smart students, very nice students, and amazing Amotech team, amazing speakers. Thank you very much for nice presentation. Thank you again. At the end of the first day, really, it is great and successful. Thank you all. Mr. Ahad?
Yes, sorry, I lost the connection and reconnected again.
Okay. Nice meeting you. Mr. Ahad, go ahead to talk or to say anything.
Do you hear me?
Yes.
I'm very happy. Thank you, kids. Thank you, guys. Thanks, everyone, for this great initiative. I really looked forward to be with you, but it's very difficult to travel during the COVID times. I will speak tomorrow a little bit about temperature calibration. And I promise as soon as I can visit Kenya, I'll be there because I am a coffee lover. So I would like to visit coffee farms and see coffee plants. And will be hopefully soon. If I visit Kenya, I saw how Dr. Usama showed us. He was in Mombasa. Very, very happy about this initiative, and would like to thank our partner Amotech team. We will speak tomorrow. You were wonderful today. Thank you very much.
Thank you very much. See you tomorrow.
Thank you.
Bye.
Thank you, everyone. Thank you. It's nice to be with you. See you tomorrow.
See you tomorrow.
Bye-bye.
Bye-bye.
Bye-bye.